Hi, so today I'm going to work on the LeetCode question number 88, and this is about the merge sorted array. So in this question we are basically given two sorted array, which is nums1 and nums2, and then we are also given the number of actual elements in the nums1 and also the number of elements in nums2. The goal is to combine nums1 and nums2 and have everything in nums1, and that too in the ascending order. So if we look at the nums1 list, there are three vacant places, and these three vacant places are basically there for to get the data or to get the element from nums2. And while doing so, we have to make sure that whatever list we end up with, that should be in the ascending order. So there are various way to do it. I think in my opinion the most easy way to do it is create a new list, and then iterate through nums1 and nums2 at the same time, compare whichever is smaller, then put that in the nums1, and then again move on to the next element and compare that. So if we go by that approach, we will end up using extra memory. So the other very efficient way to do this is start comparing from the same array, nums1 and nums2, and then whichever is bigger, we have to put that in the nums1 array at the end. So let's look at it, how it's going to work out in our sample example. I'm gonna copy this input. So here we have nums1 and nums2. So here my goal is to use two different pointer to go through the actual length of nums1 and nums2. So let's say that my first pointer is L1, which is m minus 1. So that will be nothing but 2. So basically L1 has three elements, 0, 1 and 2. Similarly, I will create another index which is going to be n minus 1, and that here also it's 2 because n is also 3. So, and there are three elements in the nums2, that's why the n is 3. But if we go by index, the index ends at 2, 0, 1 and 2. There's another index we have to carry through the iteration, that is I'll just call that index, and this index is nothing but the total length of the nums1 after we get all the element from the nums2, and that is going to be m plus n minus 1. So this is my, if we just go by this calculation, it's gonna be like 3 plus 3 minus 1, so that is equal to 6. So let's iterate through the given array for few iteration and see how it's gonna work in action, like when we are running the program. So let's call this iter1, and my goal is to compare this last element of nums2 to the last element of nums1. So it's the actual last element. I'm not talking about this last element because these are nothing but the vacant places which we have to fill. So if we compare 6 and 3, then we know that 6 is bigger, right? So in this iteration, I'm going to put the 6 in this last position of nums1. Okay, here I made a mistake. M plus n minus 1 is going to be 5. Okay, so when we put this number 6 in the nums1, it's going to be there at this position, which is nothing but the index 5, right? So my resulting array after the first iteration is going to look like 5, not 5, 6. So this is the resulting array after the iteration 1, where I compared 3 to 6. Now once we process this element, then we can move our pointer to 5, which is going to be 1, and L2 is the pointer which I'm using to iterate through the nums2, and L1 is the pointer which I'm using to iterate through the nums1, but from here to here. Alright, and as we move in from right to left, we also have to decrease our pointer L1, L2 and also index. As as soon as we fill the current index, then after that we also have to decrement the index as well. So after the iter 1, my L1 is still 2 and L2 is 1. So basically my L1 is at the 5th position. Now in the iter 1, iteration 2, we are comparing 3 with 5 because my L1 is still at 2. So it's again a comparison between 3 and 5. And when we compared, we saw that 5 is the bigger number. So that's why 5 is going to get this position. And here let me also add the index because we used one of the index. So now my index is going to be 4, which is this. So once I found out 5 is bigger than 3, then I'll put the 5 here in the 4th position of nums1. Then my resulting array is going to look like this, 5. And then after the iteration 2, my L1 is still at 2, L2 is now 0. We already processed 5 and 6. That's why we are just left with the last number. And index, we used the index in the iter 2, right? So the index is going to be 3. So my index is now here. So in the iteration 3, we are going to compare 2 with 3, right? So 3 and then 2. So in this scenario, we know that 3 is bigger than 2, right? So now the time comes where we are going to displace one of the element in nums1 and move it to a different position, which is the next index position. My index is at 3, right? So I'm going to move 3 from here. But be careful, we are not removing this 3 from here. So here my resulting array is gonna be 1, 2, 3, 3, and then 5 and 6. After this iteration, since we moved L1, right, for the first time in this example, L1 is going to decrement to 1. So now my L1 is positioned here at this location, and my L2 did not move in the iteration 3. So L2 is still at 0. So L2 is here and then L1 is here. So in the next iteration, we are basically comparing 2 with 2. So in this example, we know that 2 is not greater than 2. So what we can do is we can just move this 2 to the next position, and we can do either way. So in this example, in the iteration 4, my final array is going to look like this. Okay, and now since we moved this 2 to the 3rd position, I'm going to decrease my L1 pointer by 1, and now L1 becomes 0. And in this iteration 4 also, we moved one of the element in nums1 to a different position, but we did not move anything in the nums2. So L2 is still going to be 0. Now this comparison is between this number 2 and this number 1. In the iteration 5, I'm comparing 1 with 2, and we know that 2 is bigger, so my number will look, so we are basically moving this number 2 to this position. And I forgot to update my index. Index here is going to be 2, and here index is 1. So I'm going to move this 2 to the position 1 in the nums1, which is this location. All right, so even though if I replace, even though if I move number 2 to this position, it's going to be same, so we won't see any difference in this result. It's going to be same like the iteration 4, right? So we are basically to the end, and we in this, like in the iteration 5, we compared the last two element, right? And we moved the number 2 from nums 2 in the nums 1. So now my L1 is still at 0, but L2 is becoming -1, and that's where I'm going to come out of the loop. And here index becomes 0 because I used one of the index. So since we already exhausted all the numbers from the nums 2, there's nothing left in nums 2. So now, like, whatever we are end up in the nums 1, that is going to be my result, because like we started with the assumption that nums 1 is already a sorted arrow with whatever actual numbers we have in the nums 1. So that is basically pretty much the logic or the iteration we have to go through in order to compare. Now let's write the program. So I'm going to use first index. So this is my index for the nums 1. This is my index for the nums 2. And this is the index variable for total actual element from both the array. Okay, now I'm going to iterate through both the array nums 1 and nums 2 up until it's greater or equal to 0. And then we are going to compare the nums 1 with nums 2 and 2. So in this comparison, I'm checking if my element from nums 2 is bigger than element from nums 1. This is what I'm trying to do from that statement. So if the element from the number 2 is bigger than the element from number 1, then I'm going to move that element into nums 1 at the index position, which is 5, and then I'm also going to decrement the n2 index, because I already compared that element, and that element is bigger than the element in the nums 1, and we already moved that into the nums 1, so we don't have to iterate through that again. So that's why decrease the n2 index. Else is the scenario where either the element from the nums 1 is going to be bigger than the element from the nums 2, or it can be equal to the element of nums 2. So this piece of code should take care of both the scenario where it is equal or greater. So I'm going to put the nums 1 number from that index into the nums 1 at a different index. So this is basically the scenario where 3 is bigger than 2, right? So 3 is bigger than 2. So in this scenario, I'm pushing the 3 to this position. All right. So once I move the element in the same array nums 1, I have to again decrement the counter for nums 1, which is n1. So here we go, n1 minus equal to 1. But we can see that in either of the scenario, we are basically moving one or the other number, and that's how we are using the index. So index is going to be decrement in both the scenario. So that's why there's a common statement for index -1. All right. So this basically covers most of the logic, but there's a scenario where suppose like we iterate through all the numbers in the nums 1, but we still have few number which are left in the nums 2 that we still have to push it into the nums 1. So in that scenario, we just have to loop through the remaining number in nums2 and then start pushing those into the index variable we created. So there what we can do is that we can create another loop while n2 is greater than or equal to 0. Then we can use the last index where we inserted in the previous iteration and move the nums2 here, and we have to again decrease both the index minus 1 equal to 1 and then n2 minus 1 equal to 1, because as and when like we are filling the indexes or the position, we have to keep moving towards the left. So that's pretty much it. Let's run. Okay, so it is accepted. It's running fine on these 3 test cases. Let's also submit it. Okay, so it did work on all the test cases. Yeah, I think that's it. So this question is I know this is like easy, but I would say it's little extra, difficult than easy, because like as in like because whenever I pick up this question, I like my intuitive approach tells me to start from the beginning and then compare the first element from the second array and then keep moving the element, but that's not the right way. The most efficient approach is to compare them from the end and then keep shifting the element. All right, thank you for listening me. If you like the video, please like and subscribe. Thank you.